Hi, I'm Mike Liberante, manager in the Aquarion Water Company's Supply Operations Department. Today we'd like to show you around the Easton Lake Water Treatment Plant and how we take raw water out of the lake and making it into potable drinking water. Behind me is some statistics on the lake. The dam was put in service in 1926. Surface area is about 500 acres. It's a little more than 3 miles long. The watershed area is about 13 square miles and the capacity is about 5.8 billion gallons. The plant process is how the water comes in through the plant and how we remove the particles and the impurities from the water that we don't want you to consume. The water comes in from the reservoir by way of raw water pumps. It's pumped up to the treatment plant, and then the water flows through a series of tanks and basins where we have chemical addition and we have mixing. So we're adding chemical, we're mixing it, we're making a particle, we're getting that particle bigger, we're making it more dense and heavier, and then it's settling. From there, it goes through filtration, where the filtered water then comes out and goes into a series of tanks, ultimately to 2 finished water storage tanks, 3 million gallon storage each. From there, the water goes out to the distribution system, to the public. There's a gravity portion and then there's a pump portion. Because we are at 300 feet above sea level and we have customers that are 600 and 700 feet above sea level, so we need to pump that water up to them. So that's a quick overview of the plant. Now I'd like to show you around the facility. So we're outside getting into the plant process. The raw water comes up from down below, the raw pump station, pumps it up to that 36-inch main, comes across, chemical addition, then the water flows downward and then it comes up and flows this way into the flocculator tanks. We're forming a particle. That particle then flows across to the sedimentation basin for settling, then flows upward through these plate settlers. The particles settle out on the plate settlers, and then they settle to the bottom of this basin where they're collected and pumped to the lagoons. The settled water flows over into this channel, ultimately into the filters. Now we're back inside in the filter gallery. The water comes in from the outside sedimentation process, comes in on top of the filter, filters downward through the media. The media is 36 inches of anthracite coal and sand. That water will then flow down through the media, collect in a channel, and route its way ultimately to the finished water storage tanks where it's ready for public consumption. These filters are online for a certain amount of time, but they will have to be backwashed. The operations staff sets up the scheduling for backwashing such that at the end of the production of the filter gets automatically washed and goes back into service. If along the way any of those steps should fail, an alarm would be generated and an operator would have to come out and troubleshoot the situation and put the filter back in service. Here we are in the control room of the plant. This is where the operations staff interacts with the facility. What we're looking at now is the SCADA computers. SCADA is an acronym for Supervisory Control and Data Acquisition. This is where the monitors, the flow transmitters, the pumps, all the equipment in the facility is providing us information back here so the staff can monitor and adjust as needed to maintain consistent chemical feed and water treatment. If any condition should go outside of the norm, an alarm condition will be generated, and that will alert the staff to come and see what it is, and then they will fix the issue. Here we are in the water quality lab. This is where the operations staff does daily lab tests. You have lab sync, bringing in samples from different parts of the process. You have bench instruments, and you have inline analyzers. These are all constantly monitoring the water through different parts of the facility, and all this information is brought back to the control room, to the SCADA PCs, so we can get up-to-date information. Okay, here we are in one of our bulk chemical storage rooms. We have a bulk tank and chemical feed pumps. This particular chemical is a phosphate product used in corrosion control. This is a containment wall. This containment area is specifically designed in the event of a catastrophic failure of this tank will contain the entire contents of this tank. Of course, that situation would generate an alarm, which would then call the operations staff to come and see what happened. This is the chlorine room, sodium hypochlorite. Chemicals delivered by bulk tanker, goes into the bulk tanks. From there, the injection pumps pump the chemical to specific areas of the plant. There's 2 pumps running, and there's 2 pumps available for emergency operation.
This is the lower filter gallery. All the water that comes in through filtration is collected down below into this channel. This common channel then flows out to the finished water storage tanks. All of this piping infrastructure is related to the filtration operation. Each filter is monitored continuously. Things such as turbidity, flow, and level are constantly monitored and fed back to the SCADA PC for the operation staff. Behind me are the 2 finished water storage tanks, 3 million gallons each. The water from the treatment plant ends up into the storage tanks where it's then distributed to the public. Cement open top tank is called a recycle tank. That tank receives backwash water from the filters as well as the sample taps from the lab. That water is then tapped into the raw main and recycled back through the rest of the plant.
We hope you enjoyed the tour and gained a better understanding of the journey of water from source to tap. Cheers.